Hi everyone, welcome back to the channel. In this video we will explore how Boolean functions can be represented using SOP, sum of products, and POS, product of sums. So we will also understand canonical and non-canonical form, and we also convert a non-canonical form to canonical form, and also learn about Minterms, Maxterms with the help of truth tables. So let's get started. Let's start with a question that why we need SOP and POS forms to represent a Boolean expression. So suppose assume this is a logic circuit. So we have having many inputs. So we are having one output that is F showing there. So the final output logic may be anything. The F of the output can be any of big kind. So this F can be represented of two forms itself. So these two forms are very important to be understood because the output only the final thing that we are going to need. So the representation output is very important, so that the SOP and POS forms of representing the final output is came into picture. In the general sense, we can able to represent the output of F in two forms, that is truth table and Boolean expression. So in the Boolean expression also we have two types, that is SOP, sum of products, and POS, product of sums. These two are the things that I am saying about. These two are SOP and POS. So let's start with the basic thing, that is SOP, the sum of products. So before understanding SOP and POS directly with the help of truth tables, so let's see the definition first. So the definition of SOP says each term, minterm called, contains all inputs variables either in their original or complemented form. The output is 1 for that specific minterm. So if you don't understand, no problem, we are going to discuss these things in the upcoming video. What is meant by minterm, why we are representing 1 with the help of minterm. So we are going to see. So if you see the definition of POS, that is product of sums. So each term, max term, so each term is also known as max term, contains all input variables either in their original or complemented form. The output is 0 for that specific max term. So max term or 0 is both are same. So wherever the output is 0, we are going to say that as max term. So wherever that is 1, we are going to say that is min term. So we are going to see with the help for starting with the SOP, sum of products. If you see the SOP, sum of products, so forget about the sum. So let's see the product terms, that is A dot B, A dot B bar dot C, A dot B bar. So we are having three terms that I am showing there. So those are known as product terms. Product term means nothing but the AND gate representation, also a simple thing we can say. So if you AND those things, those are the product terms. So if you have bar of any of the term, any of the variable, A, whether A or B or C, if you have bar, that is known as complement form. If you don't have bar, that is known as true form. This is the meaning of the product terms. So the three terms that I am showing now, if you add those three terms, the product terms, if you should be added, so the added product term is suppose take an output as F1. So this is the whole sum. The final output would be a sum. So this is known as sum. So the final, we call it as sum of products. So products are summed. So that is known as sum of products. In the same fashion, we are going to see product of sums. So these are the three terms that I am taking, the same three terms. So the first, we are going to have sum terms, that is A plus B bar plus C, A plus B bar. So in the same fashion, we have to understand, if B bar is there, that is complement form. For any variable bar is there, that is complement form. If nothing bar not there, that is known as true form. So we are going to have these sum terms. So the sum terms should be multiplied. So after multiplying, you are going to have final the product term. So that is known as product of sums. So you are going to product all the sum terms, that is known as product of sums, POS. So that is A plus B into A plus B bar plus C into A plus B whole bar. That is the known as product of sums. So for the more clarity, we are going to see another example of the product of sums. So we are taking another example, that is F2. So after F2, I am representing quoting the variables that are present in the final output equation, that is A and B. So we can represent, or we can means it's our wish, we can represent or not. So in the second expression, I am representing A, B. In the first expression, if you want to represent, that is bracket A, B, C, because in the first expression F1, we are going to have three variables, that is A, B, C. So in the F2, we are going to see that is A bar plus B into A plus B bar into A bar plus B bar. So this is the second example of POS, product of sum terms. After understanding SOP and POS in a basic way, so we are going to understand what is meant by canonical form and non-canonical form. So let's start with the canonical form. So basically we have to understand the definition first so that we can able to proceed further. So they represent Boolean functions in a standard way, either as a sum of Minterms SOP or product of Maxterms POS. So in a standard way means, so basically all the terms should be present in that, all the variables should be present in the all terms, that is known as canonical form. So let's see an example. This is the example of the canonical form. So basically that I am representing, that is f2 a b. So we are having two variables, that is a and b. So we are also having two terms in that. The first term is a bar dot b, in the second term that is a dot b bar. So we can able to understand in between we have plus operator, that is sum, in between we have sum of products. So that is also we can understand, that is SOP, that is sum of product. So and also all the variables are present in all terms. So in the first term, that is a bar b, or we can have anything, that is a b bar, we can have anything, but we should have the terms of a and b. So in the second term also we have the terms of a and b, so that is known as canonical form. So these are the other three examples so that you can able to understand what is meant by canonical form. So even though if you don't understand, so after seeing the non-canonical form you might be understood, because the clear cut difference would be understanding with the help of non-canonical form only. So let's see these canonical three examples also. So in the f3 we are going to have three product terms, and we are having that plus operator, that is SOP. So first f2 and f3, that is in f3 also we are having in the bracket itself we are having three variables a b c. In the all the three terms also we are having a b c. The first term we have a b c, in the second term we have a b c, in the third term also we have a b bar c. Anything we have complement form or true form, nothing, it doesn't make sense, but you should have three things or three variables in the every product term. So in the f4 and f5 are the POS forms. So that is we are taking first sum, and after that we are going to multiply that. So in this fashion also we are going to have every term in the every variable should be present in the every term. So let's start the non-canonical form. So I will read the definition once so that you can able to understand what is the main motto of non-canonical form. So these deviates I have highlighted with the red color also. See that deviates the canonical forms, the missing sum of the input variables, making them less straightforward. So let's understand what is meant by this with the examples. Assume if you have an example, that is f1. So in f1 we are going to have in the bracket, that is a b and c. So after bracket also we are having three terms, that is a, the first term, the second term, the third term. But in the first term we are having only the variables a and b, but in the brackets we are having three variables, that is a b c, but in the first term we are having two variables. So this is not valid, so this is known as non-canonical form. So this is valid in the non-canonical form. So in the third term also we are having only two variables, but in the second term, yeah, it is true. Okay, so whether it is in the it is in the complement form or the true form, but it should present three variables in every term. So in this c term is missing. If we want c term, also we can multiply required term with the c plus c bar, because we know the Boolean algebra, that is c plus c bar is equals to 1. If you don't know about that basics of Boolean algebra, so the video I am giving in the description, check it out. So as I said, we are going to multiply with the non-canonical form terms. I am saying the terms has to be multiplied with the required or the non-sufficient things we have to multiply. So in the first term we are lagging or insufficient with the c. So we are going to multiply the first and third terms with the c plus c bar. So if anything is lagging in the any term, we are going to multiply with that terms only. So in the first term you are going to lagging with c, so we are going to multiply with c plus c bar in the third term also. So after multiplying, it's like just normal math, just multiply inside that. So after multiplying, the second term and the fourth term are same. So we also know Boolean algebra, that is if both terms are same we are going to have only one term. So one time, so write that one time, so that is a final output equation. So if you observe carefully the final output equation and the first equation that I mentioned side by side, that is non-canonical form in the canonical form, the in a red highlighted way, that you can able to observe very clear difference. That is, in the first term we are having the a b only, in the last one that is a b c, so we are having all the terms present in the all variables in the all terms. So this is known as canonical form. So let's also see another example for the non-canonical form. So we also have f2, that is a plus b, that is s. So first term is the f1 is, that is SOP. So the second term f2, that is POS, that is a plus b into a plus b bar plus c into a plus b bar. So that is POS of non-canonical form. So based on all this canonical, non-canonical form combinedly, we have 4 types, that is canonical SOP, non-canonical SOP, canonical POS and non-canonical POS. So these 4 types of things that we have discussed up to now only. So up to now what have we have saw with the examples also. Those also in the first itself I have discussed, in the canonical form I have discussed the canonical SOP and non-canonical SOP, both of the terms. So in the non-canonical also I have discussed both of the examples, that is canonical and non-canonical POS, both examples I have discussed there. It's not a tough concept, that you have to remember that all the variables should be present in the all terms, that is canonical, if not that is non-canonical. The basics we have completed on SOP and POS. So we have understood what is meant by SOP, the sum of products, and POS, product of sums. So now, we have to represent a Boolean expression in the terms of SOP and POS if any truth table is given. So for that we are going to have, suppose, not just after we will see an examples, before that we are going to have just what is meant by Minterm and Maxterm. So up to now what we have saw in a sum of product, that is SOP. So that is, if you take an example, that is f1. So if you see that we have saw this example already. So individual terms are known as Minterms, so that is represented as small m. So in the POS, the individual terms, that is a plus the sum terms, are known as Maxterms, so that is represented with the capital M. So then now I am going to start the main concept of the what is meant by Minterms. So the first the Minterms is applicable only for SOP, that is sum of products. The first concept we are going to learn, that is SOP only. So Maxterm is different, Minterm is separately different. We have to understand the SOP first. So if you see there, before seeing the truth table, so you are going to see, so I take an example, that is 0 is represented as a bar and 1 is represented as a, if a is the variable. If b is the variable, we are going to represent 0 as b bar and 1 as b. So this is the simple representation we are going to follow. So if you see the truth table, we are going to have 3 variables. So we are going to have a logic, we don't know what is the logic, but we are going to have some output, that is f1. So the a b c 3 variables we are going to represent. So as this is a sum of product SOP, we are going to represent a as. So in the first column we are going to, in the first row we are going to have 0 0 0. So output is 1. So forgot about output column, that is f1. So see, just a b c, those are 0 0 0. So as I said, that is 0 as we are going to represent variable bar. So I am taking a bar, b bar, c bar. So I have highlighted in the red colored manner. So if you take the last one, that is 1 1 1, that is 3 variables a b c. So I am going to represent that as a b c 1 1 1. So if you take anything, that is if you take the last but one, that is 1 1 0. So I am going to represent that as a b c bar. Likewise you can observe anything. If you see the second thing, that is 0 0 1, I am going to represent that as a bar, b bar, c. So in the sum of product SOP only, we are going to have something called the Minterms. So we are starting with M0 and we are going to end with the 7. So from that we can understand. So the variables are 3, that is A, B, C, 3 variables. So we are going to have 8 Minterms, that is from 0 to M0 to M7. Yeah, I also mentioned the statement that's itself. For this case, we have 3 variables, that is A, B, C. So as 3 variables we have, that is 2 power 3, 8 Minterms we had. So for n variable, that is if you have n variable, that is a b c d, like that. So the variables are n, so that we are going to have 2 power n Minterms. Yeah, I hope you understood what is meant by minterm. So let's see an example how to represent a Boolean expression or the truth table. So in a simple manner, so that we can understand these things are these concepts we can use in the K maps, and very big concepts we can represent a big things in a simple manner. So let's see the sum of products in the representation of sum of products. So if you observe, I took an example, the truth table output. If you see, so I have highlighted in a maroon color, that is the first the one where we. So if you don't understand, so let's read the definition once so that you can understand further. So I have mentioned before itself the definition. So here I am saying orally, that is where there is one. Where there is one, you have to put there the minterm. That is our first minterm. That is one minterm. So if you observe, we have at the place of m0 we have 1, in the place of m2 we have 1, in the place of m4 we have 1, in the place of m7 we have 1. So how many terms we have? 1. There we have to take as it as a minterm. So I have highlighted the thing, that is the a bar, b bar, c bar. So in the normal form also, that is the expanded form also. So we can represent in 3 forms. So the first form is normal form. So in F1 we have at 0 position we have, that is a bar, b bar, c bar. In the second position, that is M2, so we are going to have that position, that is a bar, b, c bar. In the third, now in the fourth position we have, that is a, b bar, c bar. In the seventh position we have a, b, c. So okay, we have understood this. So we can also simply represent this. The first term is what? That is m0. So we can replace that first term with the m0. So that is second term. So replace m2, the fourth term m4, the seventh term, that is m7. So in the math, the sum of terms can be simply represented with the help of sigma. So as I took the sigma representation, that is sigma of 0 to 47. That also denotes the summation. That's it. For more clarity in the SOP only, we are going to see another problem with the help of truth table, so that we can able to understand very much clearly this concept, that is SOP. So here they have given the SOP format of things, that in the first, second and the sixth positions we have ones in the output of F1 column. The corresponding I have highlighted with the black color also the expanded formats. So I have taken the F1 as 3 terms, that is in the first, second and sixth one, that is a bar, b bar, c. So that is corresponding to m1, m2 and m6. So you can understood with the help of above example only, as the similar as above example only. So the same positions we can replace with the minterms, that is m1, m2, m6. So I can reduce more with the help of sigma notation. So that is 1, 2, 6. So this simplifies our more. So this much truth table can be represented as this simple format, so that we can represent our Boolean expressions in a simple formats. So our representation becomes smaller, so our understanding becomes more. So for that purpose only, we are going to have 2 representations, that is SOP and POS formats. I hope you understood the SOP formats. So let's start with the POS product of sums. So let's see the truth table of the POS. So before seeing the truth table, we are going to understand it's not like SOP. So it is completely opposite of SOP. So if you see a variable that is A, so if 0 has to be represented as A only. So 1 has to be represented as A bar. If you observe, that is simply the reverse representation of SOP. So you are going to apply, and you also not going to do dot product, you are going to sum of them, because this is product of sum. So I have highlighted in the expanded form also, you are going to have, that is a, b, c, 3 variables. So we are going to have one output column, that is F1. So the first 3 variables a, b, c, that is first row, that is 0, 0, 0. So we are going to represent, that is a. If 0 is there, we are going to represent a only. So we have to have a sum, because it is product of sum POS. So we have to add 3, that is the first term 0, 0, 0. If you observe the last term, that is 1, 1, 1. So we are going to represent 1 with the a bar, if a is the variable. So a bar plus b bar plus c bar, this is the representation of product of sums. So likewise, all the representations can be filled as shown in the above that. So F1 column, I have took some example, that is F1 output. In the same fashion we have already saw. So we are going to represent POS with the capital M letter. So in the same fashion I have wrote with the capital letter from 0 to 7. So this is the representation of product of sums. So in this also we are going to have for 3 variables 8 product of sum terms, that is max terms also we can call them. The same statement that we have saw for the SOP also. So the statement is we have three variables in this case, so 8 max terms. If you have many more terms, that is the 2 power n max terms. If you have two variables, that is a and b only, suppose, so you are going to have only 4 max terms. So we have two examples. So let's see the first example so that you can boost yourself. So you can represent any of the given truth table in simple POS format. So assume that they have given this format, that is they will I think I forgot to mention a note. So they will not mention that a plus b plus c and remaining all things, that is highlighted in a red fashion way. So just I represented like that. So that m's also you have to represent in exam format. So the output also they will not give. So we have to find the output. So the table also they definitely will not give. We have to know we have to know the representation of the truth table. So after representing the truth table, we have to represent the output based on the given logic circuit. So where there is zero, that is our POS term that we have to understand first. So if you have observe, in this case, in this first example, we are going to have zeros in the first, that is m1, in the third, that is m3, in the fifth, that is m5, in the sixth, that is m6. The correspondingly the expanded formats highlighted in a black way, that is a plus b plus c bar, a bar plus b plus c bar, and a bar plus b bar plus c, and the remaining thing, the four expressions has to be represented in the product format as shown in the F1 format. So this is the representation of POS, product of sums. So or you can represent in the format of products, that is the first term, that is we can represent simply in the capital M1, the second term, that is capital M2, and the M5, that is the fifth term, M6, that is sixth term. So you can represent this is, as these are products in general mathematics, we can represent the product terms with the help of pi. So here also I am going to represent with the help of pi only. So this is the second example in the POS, product of sums. So you can see that I have chosen three terms, that is the second term, fourth term, seventh term. So the corresponding the sum terms also I have highlighted in a black way, that is a plus b bar c, a bar plus b plus c, and a bar plus b bar plus c bar I have selected chosenly according to M247. So after that I am going to represent in the form of POS, so that this whole table can be represented in a simple format, that is F1 is equals to pi of 247. That's it. So you can observe I have written there with the product terms. So after that I minimized with the help of Boolean terms, the max terms we can call them. So that is second 4 7, so that I multiply with M2 4 M7. So simply 247, pi 247, that is the simple representation of this whole table. So this is the third example. So remember one thing, in the SOP we are going to take 1 as our the sum or the main things. So in the POS we are going to take zeros as our things that we are going to write in the output. So this is the main difference we are going to keep in the mind, the first thing. So and the expanded things also, and the product term and separate terms also, the sum terms also we are going to have in POS, that is the sum terms, and the product we are going to have the product of sum terms. Here we are going to have product of sum terms. That is a key important point here. It's a very important point. They might be confusing in some of the gate exams or very important exams also. This part might be confusing. So between POS and SOP. So I hope you can do this thing, that third example. So I have took M4 and M7 as our zeros. So just represent those two as the POS, product of sum, minimize them with the help of max terms, that is 4 and 7, M4 and M7. So represent as that is product terms, you can represent in mathematically, that is pi 4 7. So this is the simple representation of that third example. Yeah, this is the thing that I am talking about. So let's consider a general example. So we are going to apply in this only both SOP and POS. So this is the simple trick that you can remember for all the examples. If you are solving anything, any truth table, so you want a SOP or POS format, so you can that you can represent in canonical or non-canonical forms. So this is the general example that you can see. So just let's consider anything, just write SOPs, that's it. Just write the small letters, that is M0 to M7. So in this where you have ones, so at that places just write the summation, that is in this example we have 1 to 6 positions, that is sigma 1 to 6. So this is the representation of SOP, this table in the simple format SOP. Remember each and every term, the first term we have a plus b plus c bar, or anything we can the corresponding to 1. If you take the first term we have 1 to 6, in the first one, that is 1, If you observe 1, that is 001. So we have to represent the expanded format as A bar, B bar and C. So that is the term, first term. And the second term, and in the second output format, that is 2. So that is A bar, B, C bar. That is the third one is, that is 6. So if you observe 6, that is 110. So A, B, C bar. So we have to add these 3 terms so that we can able to get the final output F1. So we have to remember that it is in canonical form. Whatever may be the thing that we are taking as this format, that is sigma notation, that is always canonical forms only. So I hope you understood the canonical form. So canonical form is all various variables are included in that. So in this also, in this representations also, we are including all the variables in that. So it is canonical form. So I have said anything we can, any table we can apply this logic I said. So take M0 to M7 I said, you know that. For the POS format, just so in the places of 0, you have to take the product terms. So just opposite. So you know from 0 to 8 what are the numbers. So we have already know the SOP, where there is 1, that is SOP. So where there is 0, that is our POS. That's it. If you observe that F1 of SOP, so we are having 1 to 6 in canonical form. So if you want POS, just know, if you know 0 to 8, so just alter or remove the 1 to 6, the remaining numbers will be fall under all POS. Or you can see in the table also, the M0, the M3, the M4, the M5, M7 are zeros. So that is our POS format. So we can, without table also, we can simply, by seeing SOP format, we can obtain the POS format in canonical form. So I hope you understood the canonical form, what is meant by canonical form, POS, SOP representations, with these examples also. So with that I will close this session. So, and also these representations are very helpful in doing K-maps. So in the upcoming video K-map, we are going to use this SOP and POP formats. So stay tuned. If you want the full table for the reference, so this is the full table, that is involves 3 variables A, B, C. So I included Minterms, Maxterms as well, the expanded things and the small representations, all this in a single table. Thanks for watching up to now.